Welcome, students. We will start our lecture on sets, and you know that sets is the first and the basic in mathematics, or we will say in class 11th. The name of the first chapter is set, and everything is defined over set. Whether you want to define function or anything, types of sets, whatever it is, the main is set because function is defined over set, union is defined over set, intersection is defined over set, uh, and all other things, different types of functions, everything is defined over set. Without set there is nothing. Trigonometric functions are defined over sets. So first of all, we are studying mathematics. So I hope that you know about the definition of mathematics, but we will discuss the basics of set. What is set? What is set? It is not writing as much as good on notebook, but it is set. I'm talking about set. We know that the definition of set is a well defined collection. A set is a well defined collection. C for collection. I will write in short. A set is a well defined collection of well distinct objects. Well distinct objects. Or we say a set is a well-defined collection of well-distinct members or objects is known as set. This is the definition of set. But here the question arises: a set is a well-defined collection. What is the meaning of well-defined? What does well-defined mean? And another word is well-distinct. These two words are the basic in this definition and meaningful in this definition. Otherwise, without the meaning of these two words, this definition is not clear, right? So well defined here means well defined. This is well defined means it gives us the guarantee. As we buy something from a shop, they give us guarantee that if this item will be defected within this stipulated period, within some period, then you will get your money back. But here well defined means the thing about which we are talking, that thing is actually that thing about which we are talking. Suppose I am saying in my hand there is a coin of 2 rupees. In my hand there is a coin of 2 rupees. This coin is in my hand, right? And my hand is fully closed. Nobody knows what is inside my hand. But if I am saying it is well defined that there is a coin which is in my hand, when I am using the well defined, it means now there is no doubt that there is something different. No, it will be exactly the coin. It gives us the validity of that particular thing about which we are saying that this is coin. Or I will say this in my hand there is a pen. If I am saying it is well defined that there is a pen in my hand, now the listener has no doubt. He can't say or she can't say that there is pencil. No, when I used well defined, it means there is guarantee. This has been proven that in my hand there is a pen, right? And same is the case when we talk about the well defined collection. It means there is a collection. It may be collection of pens as the definition states. It may be the collection of pens as we have here used. A well defined collection, it means there is a collection. What? There is a collection. There is a collection. So there is a collection. What? There is a collection. Now, So there is a collection, right? There is a collection, well defined collection of well distinct objects. It means there is a collection of objects. It may be collection this wait it is a collection of objects, sorry. It is like collection of pen. There are some pens, there is some pencil, there is some pant, shirt, chalk, and cell phone, C for cell phone, and S for speaker. This is collection, right? This is collection. It is well defined. Well defined means now there is no doubt that I am saying this without any proof. It is well defined that this is a collection. It means now there is definitely a collection. When I am using well defined, it means it is definitely, there is definitely a collection. Whenever I will use a well defined collection, it means there is a collection, right? This is collection. Now the next is next thing is well distinct objects. Note down that these are the objects. These p p t c c s, these are the objects. These are objects. Now the next word is well distinct object. That means these objects, what, these objects p s t etc etc, what are these? These objects are mutually distinct, well distinct. That means if I have a collection this, and I am taking this, these are some objects. If I will take any two objects, they are totally different. They are totally different. That means if this object and these objects are different, this object, every two objects, any of the two objects you choose from the collection, those are different. What? Those are different. What? Those are different. That means they are well distinct. Well distinct means they are different. If they are different, it means they are not same. What? If they are different, it means they are not same, because the definition states that a well defined collection of well distinct objects is known as set. Well defined means, first of all, I have a collection, well defined collection of well distinct objects. Now first of all I have a collection, after that the members in the collection are distinct, and that collection is well defined. Now this means I have a collection of distinct objects, well defined collection of distinct objects. Now one question is one question arises here. Why the collection, uh, why the repetition of elements, why the repetition of members or objects in the set is not allowed? The question is, the proof is because these are already well distinct. Well distinct means they are totally different. If they are different, it means they are not same. If they are not same, then how the repetition is possible? No, not at all. Because for repetition, elements must be same. But the definition, first of all, the definition states us that the elements are not same, they are different. It means if they are different, it means they are not same. If they are not same, then repetition is not possible. It is not possible. N possible, N for not possible. Repetition is not possible because elements are different. It means they are not same. They are not same. If they are not same, then repetition is not possible. Repetition is not possible, right? Then repetition is not possible. Exact. Now, and it follows conversely. If elements are repeated, it means they are same. If they are same, it means they are not distinct, but it violates the definition. Because if there is something, we have two same things, that is why then they will be repeated. Because if I will have p1 here in the collection and p2, p1 and p1, why it will be repeated? Because it is second time here. That means they are not same, it is same. It violates the definition. But here everything is different, it means the repetition is not allowed. This is the reason why the repetition is not allowed. Repetition is not allowed because we have well defined collection of well distinct objects. Well distinct objects, right? Because well distinct here states that the collection, under the collection, the things which you are considering, they are well distinct. Well distinct means they are different. They are different. Now we will talk about the example of sets. I will and note, the set is always denoted by capital letter, like A, B, C, D, E, and F. Whatever you take, but it will be capital letters, right? it will be denoted by capital letter. And there are different types of sets. Like I will take as example of set A is equal to 1, 2, 3, right? A is equal to 1, 2, 3. That means this set has three elements, and choose any two elements. They are different. One is different from two, two is different from three is different from one. All are different, right? Number of elements in the set is known as cardinality. What? Cardinality. 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 And it is denoted by this cardinality of A 1, 2, 3. This is known as cardinality of set. Number of elements in a set is known as cardinality of set. Or very rarely we use in higher mathematics order, but that is used in group theory. Or simply we will say number of elements in A, or we say number of objects in A, or we say number of members in A, right? This is 3. This and this both are same, right? Both are same. Now there are finite sets. Two types are there: finite set, infinite sets. Finite set finite set finite set means a set is said to be finite. Note that here it is not coming clear, but whenever I will start my proper teaching, then it will come clear. A set is said to be finite if the number of elements are members. You can say if the number of elements, a set A or B, whatever it is, a set A is said to be finite if the number of elements in A are or countable in number, right? If the elements of the if the set is said to be finite if the elements in the set are countable in number, that is we can count the elements. That is 1 200. How many elements are there? 100, 200, 300, 400, 500, 15, 16, 10, 11. That is countable, so that we can count those elements, right? Now example of finite set is, let's A is, it is not necessary that A will be set, it will be D sum. A is same example I will take 1, 2, 3. This is set. And note that set is written with these brackets, or you can say braces. There are two plurals. Braces are brackets, curly brackets. Whenever you are writing this set, it will be written in the form of curly brackets. What is the cardinality of this set, or you can say number of elements in this set? It is 3, and it is finite because there are 1, 2, and 3, right? If the cardinality of a set is natural number, we say it is finite. It is finite. This is finite. Second example I will take. D is equal to 2x z 1a. This is a, small a, right? What is the cardinality of D? Cardinality of D is equal to n of D. That means number of elements in D, number of elements in D. This is D. How many? 1, 2, 3, 4, and 5. It is also finite set, right? This is also what? This is also finite set. Now infinite sets are there. Infinites which are not finite. Simple. Infinite, or you can say infinite sets. Infinite sets. Infinite. Same. D is equal to 1, 2, 3, 5, 9, up to so on. We don't know what is the end of this set. 1, 2, 3, 4. These three dots means it is continuously going. We don't know about it. It is infinite set because it is not finite. We don't have the last member of the set so that we can count how many members are there. So it is infinite set, right? This is infinite set. Second thing is infinite set. How to write the sets? How to write the sets? There are two forms. How to write the sets? One is roster form. Roster form is the form which I used before this. Like one is ROOSTER, roster form. Right, roster form. Like I am taking D is equal to with curly brackets. Right, one, two. In a roster form means discrete, point wise when we write. This is roster form of a set D. Right, roster form. Second one is set builder form. SB. This is B. Right, SBF. This is set builder form in short. Set builder form means we are writing in this way. Suppose I have set D is equal to 1, 2, 3 and 4. I want to apply some condition on it so that I will not write this in the form of roster form. In point wise form I don't want to write it. So how I will write? I will write D is equal to same curly bracket. What are these? These are natural numbers, all natural. I will write X. It will represent all those numbers such that it belongs all wait, X belongs to N, all those natural numbers such that with condition X is greater or equal to 1, less or equal to 4. Close set. This is the example of set builder form. See this way we will write it. 1, 2, 3, 4. See how it is written and why it is written. Let me explain you. Right, see, this is X belongs to N, all those natural numbers. That means 1, 2, 3 and 4. This represents these natural numbers with this condition. Condition is written always on the right. These two dots are used to represent that right side we have a condition such that with this condition, right, with this condition, all those natural numbers from N we will take which will be greater or equal to 1. So 1 will also come because there is equality. X is natural number, greater or equal to 1. 1 will also come because equal 1. 2 greater than 1, 3 greater than 1, 4 less than 4. These all will come, and it is saying less or equal to 4. All those numbers which are less than 4 and equal 4. So 4 will also come. Here is also sign of equal to. So this is set builder form. There is here the argument is written, input is written, element is written, and here the elements are written, and elements must satisfy this condition. Right, this condition, like we say X belongs to N such that X is greater or equal to 1, less or equal to 5. If it is 5, then we have to include here also 5. All the members are less than 5 and greater or equal to 1 and including 5 because sign of equality. Now I will take one more example where sign of equality will not be there. Suppose X is some set. X uh, X X belongs to whole number. Right, here note some notations are there. Whenever we have to before this I will tell you one more thing. This sign is means belongs to. This is used to represent that some elements belongs to some set. Like I had D 1, 2, 3 and 4. Right, this is some set. If I want to write, because 1 belongs to this set, that means 1 is in this set, 2 is in this set, 3 is in this set, 4 is in this set. If I want to write in mathematical symbols that 1 belongs to it, I will not write 1 belongs to D. No, this is incorrect. This is written by those who don't know about the mathematics, but we are mathematician, so we will write 1 belongs to D. It means 1 is the element of D, 1 is the member of D. Right, And there are different types of sets, but let me take you one more example of roster form. Like D is, I will write in roster form, then I will change this in set builder form. 0 1 and 2, right? This is roster form because I am writing this point wise roster form. Now I want to write this in set builder form. See, this is X belongs to W. W means whole number, set of whole numbers. All those numbers of whole numbers which satisfy this condition: X is greater or equal to 0, less or equal to 2. Right? See, all those whole numbers which are greater than 0, less or equal to 3. Greater or equal to means we can take all those numbers greater than 0, 1, but less than 2, greater than 0, less than 2, there is only one, but condition is greater or equal to, it means equal sign we can take also 0, here equal also we can take also 2, we can't go beyond 3. Why I am not taking here 3? Because condition is between 0 and 2, but including 0 as well as including 2. But 3 is out of bound, 3 is greater than 2, but the condition is not that. So this is set builder form. And note that the condition for the elements is always written on the right. So this is and there are many more sets. Empty set, or you can say null set or void set. Empty set, null set or void set, these are those sets. This is same name, empty set you can say, null set or void set, having number of elements 0, that means that has no element. And the notation for empty set is written as this: phi or simple brackets empty, right? And there is also singleton set. Singleton reflects there is only one element, right? A is equal to X only, X is the element, or D is equal to 1, only one element, sorry, no comma here. Comma is used to bifurcate the elements, but here it is only simply one element, so no need of comma, right? So D is this. This is a brief about the sets. And then further, set has a big character that it is function, it is used in function, defining the function, right? So this was a brief recapitulate, and I hope that you will get it. But there are many more basic things as we will go for continuously we will study those things, like notations will come in mind and I will elaborate each and everything. And thank you, I hope you like it.